Hello everyone, welcome back to my SDL2 on Xcode series. In this tutorial project, we're going to build the classic snake game on Xcode using C and SDL2. This is episode 11. In this episode, we're going to draw the snake on the game scene. Let me try to run the game and see what we mean by the snake. So you can now see that within this green background, you have a blue snake here, and also an apple or a fruit here. So this is what we are going to achieve in this episode. To do so, we're going to add two more files. One is called this snake.h and the other one is snake.c. If you look at the header files here, we see some definition for our snake. First of all, we have the new enumeration type called snake direction. There are four directions here: left, right, up, and down, indicating the only four directions a snake can head. So, and then there are some functions to control the snake. For example, we have snake init function to initialize our snake. The clear function is to clean up the memory claimed by the snake. Some getter functions return the length and also the number of fruit eaten by the snake. We have a function to tell whether or not the snake can move. And there are two possibilities that the snake cannot move. One is that it is running outside of the boundary. The second case is that it is running into itself. That is the only two cases that the snake cannot move. The snake move function will actually move the snake one step forward. And we have a function to change the direction of a snake, a function to generate the fruit after we have the snake eat the fruit. And finally, we have a function to help us to render the snake on the screen. Now, you can see that to initialize the snake, we need to have a game map structure. Let's try to review what we have in the game map. We define the game map in the game header file here. You can see that alongside with what we have for last time, we have two more new fields here. These 5 fields actually define the number of row and number of column for the map, and the grid size defines the dimension of each square within the background. And finally, the offset x and y is the position where we should draw the map on the screen. And the two added fields here will represent the position of the fruit, in this case, the apple. Now let's come back to the snake header file. And you can see that using this structure, that would be enough for us to initialize our snake. Let's see how we actually initialize it. To do this, I also need to define some structure to hold our snake. In here, you can see I have some macros defined beforehand. We have the snake initialized length to be 4 and the direction to be right. And here we use this macro to define the maximum length of our snake bodies. A snake body just means a row and column to indicate the position of this snake body. Now, to hold a snake, we're going to have these fields here. We need to know the game map so that we can initialize our snake correctly into the map. And we have an array to hold the body parts. And you can see here that we set it to be at most 1,000 body parts. You can easily change this by changing the number here. Now, for the length and the fruit eaten, that two numbers are used to keep track of the snake length and also the number of fruit eaten by the snake. And finally, the snake direction will tell us the direction of the snake currently heading. And they are the structure for the snake. Since we have only one snake in our game, so we are going to initialize our snake instance already here. And the snake init function, we are going to manipulate this structure here. As a matter of fact, all the function exposed in the header files will manipulate only this instance. It is shared among the game. Now, how can we initialize it? Well, first of all, we will set the snake game map to the map that is input from here. And then we're going to query the direction. And the direction we're going to query is the snake init direction. What this function does is to get the change in one step in row and column in that direction. Let's go to the definition and see what it does actually. Now you can see that it's quite simple. You can see here that if the direction, say, is left, then you can see here that the dr will set to be 0 and the dc will be set to be -1. It is because if the snake is going left, then it will remain in the same row. So it won't change in row. So that is the reason why we have 0 here. But if it is going left, the column index is decreasing. And that is the reason why we have -1 here. And the same for other direction as well. And that's how we query the direction of a snake. Now that will help us to build the snake on the map. Now we are going to now set the body part. We have the tail and we also have the head of a snake. By convention, I'm going to use the lower index to represent the tail part and higher index to represent the head part. For example, if the snake is of length, say 5, then body 0 means the tail of this snake and body 4 means the head of this tail. Now, I'm going to start from the head and to the tail in this way. If you can say I is equals to the snake in size -1, then you can see that this will be 0, right? So basically this part will go away. That will guarantee that the snake is roughly at the center of the screen or at the map. And then we're going to lay down the body part according to the DRDC as we query from here, and that will correctly lay our snake on the map with the head centered at the scene. Now, we initialize the length to be this snake in size because that is the current length and currently initialized. And in this state, the snake hasn't eaten any fruit yet, so we set it to be 0, and the initial direction would be this snake in direct. Now, after that, we need to generate a fruit on the map. And let's take a look at this function here. So to define this function, I'm going to have some global variable called grid occupies. And this global variable only visible to this file. So don't worry about you are going to see this in other file because we have a static here, meaning that this is only local. Now, first of all, to generate the fruit, we are going to set the grill occupied to be false, meaning that there's no grill occupied. And then we're going to compute the empty slot that we can place a fruit in this map. We're going to compute the total number of grills and minus the snake length, and the remaining would be the places where we can put the apple. If there's no place for us to do it, then we just set the position of the fruit to be -1, -1 to indicate that we cannot put a fruit on the map, and then return. Otherwise, we're going to say, first of all, set the position that occupied by the snake to be true, so that we won't accidentally put the fruit on the snake. And then we're going to randomly select a place to place the apple, and that is the procedure to take out that randomly chosen position. And that is how we generate the fruit on the map. And you can see that the result is stored in this snake map and then fruit row and fruit column. Remember that this is two newly added fields to our game map structure. Now let's come back to the init function. After we do this generating fruit, we return true, indicating that we successfully initialized our snake. And in this case, there's no memory claimed by the snake, so we don't need to do anything in our snake clear function. These two character functions are simple, so I'm going to skip them. It just return the length and the float eaten correspondingly. Now, how can we tell whether or not our snake can move? Well, we have a function that will tell us where the head position is in the next move, and this is the snake head next function. Now, once we get the snake head in the next move, then we are going to do two scenarios. First of all, we need to determine whether or not the snake is out of the map. Out of the map means that we have the head position out of the boundary of our map, and then we just need to check whether or not it is less than 0 or bigger than or equals to the maximum number of the map row, and we do the same thing for the column as well. If it ever happens out of the boundary, then we just return false, and that is the first case. And the second case is we need to determine whether the snake bites itself or runs into itself. To do that, we just need to make sure that the head position is not the same as the body position in the next move. And you can see that when we move the snake, the tail will disappear, or in the sense that it get moved to the next body part. So to do the checking, we actually go through the I equal 1 to the head, because this is the body parts after we remove the snake, and 0 will be the snake part 0 will be empty again because the tail will goes away. And then we'll check that whether or not this will coincide with the head. If it coincides, that means the snake is going to run into itself, so we will return false, indicate that the snake cannot move in that case. Otherwise, we just return true, saying that the snake can actually move. So the function here is the function we actually move the snake. It is quite simple. First of all, we need to know where the snake head is in the next move. And then we need to determine whether or not the next move will eat the fruit. So that basically means whether or not our head position will be the same as the fruit position. So that will tell us whether or not we are going to eat a fruit. If we are going to eat the fruit, all we need to do to move the snake is to change the this fruit position into a head position. To be more precise, we just say, you can see that now I'm going to add this position to our snake, and then we increase the length and also increase the fruit eaten. And then since we have already eaten the apple or the fruit, we need to generate a new fruit in this case, and then we just return. And that's how we move the snake if we are going to eat a fruit. However, if there's no fruit in front of us, then we need to actually move the body part. And basically, we can move it one step forward. You can see that the tail position now will be the second to the last position in the current state. So you can see that I have to put the I index to be the I plus 1 thing. And then that will make sure that the snake will move, but not the head. You can see that here, we do not include the head here. Now, in order to move the head correctly, we need to set the head position to the head R and head C as we query in this step, because this step will give us the head in the next position, next move, so that we'll do it correctly. And that's how we move the snake. Now, to change the direction, we just can't simply change the snake.dir. We need to make sure that we can actually change the direction. For example, if you're going right, then when you change the direction, you cannot go, say, up and down. And that is the reason why we need some checking here. So we have an array here that will give us the opposite direction of each direction. For example, up the opposite of going up is down, going down is up, and etc. Then we need to make sure that the current input direction is not the opposite of our snake direction. Otherwise, we just return. Or if the direction is already the same as our snake direction, then we don't need to change it anyway. So in these two cases, we will just return directly. Otherwise, we will successfully change the snake direction to be the input direction here. And that's how we do the change direction part. So I have already gone through about this function. And let's look at the render function. This render function is a little bit complicated. And in this case, we just see a simple function here because all the complicated code goes into this part here. We need to know which texture or which snake body texture we need to use for a given body part. If we do know this one, all we need to do is to find the grid of our body part and then render this body texture at that location here. So the hard part will comes into here. How can we get the correct snake body texture? Now let's look at the get snake body texture here. In this case, we need to get into three situations where the index is 0. That means this is actually the tail, because we see that the index, when the index is 0, the body part 0, indicating the 0 part, right? Then we need to, and for the tail, we have 4 directions. Let me show you the tail. Go to snake here, and we have tail down, pointing down, and the tail pointing left, tail pointing right, and tail pointing up. So which one should we use? Well, that will depends on the tail in next move. If the tail is going to moving right, then we should have a tail pointing left, right? Let me show you again. So for example, this one, right here, this one, if the tail in next move is going into here, going down, then we should have a snake pointing up. So that is a little bit confusing, but it's easy to look at the picture and visualize it. This tail should going down. And with this information, it's enough for us to determine the tail ID. You can see that I put the tail ID as in here. If the snake is going right, I should have the tail pointing left, and etc. And then we will use this get body direction to determine the direction of a given part, and that will give us the correct tail. And this get body direction is defined in here, and it is quite simple. I'm not going to go over it. It basically determine the body direction based on the current index and the next one. And because in the next move, the body part will come from here to here. We just compute the relative position, and then that will give us the direction. Then if the index is the head, then we are going to do the same thing. We are going to get the direction of our head and then return the correct head texture, pointing left, pointing right, pointing down, and pointing up. We are going to do so in here. The hard part is about the body part, except the head and the tail. For that, we need to make sure 2 things. We need to get the direction of the current body part, and also we all need to get the direction of the previous part. Actually, this one should be previous, because lower, sorry, it would be, well, depends on how you view it. So this one is closer to the head, and this one is closer to the tail. So depending on how you view it, next means that if you view from the head to the tail, then that would be the next body part to our current body part. And that will give us the the direction of the current body part and the next body part. And we need to determine the texture based on these two directions, not just one. Unlike these two, you can see that unlike these two, I just need the current direction. Why do we need that? Well, let's go to the body part, and I'm going to show you why. If you look at, say, this one here, you can see that this one will require two directions. One, if you look at this end, it's going down. If you're looking at this one, it's going right here, right? So if the snake is going this direction, you are going to use this texture. So you need two directions. Or you can view it the other way. If the snake moves this way, then the current direction is going left, and the next direction is going up. So depending on how you view it, this will show up correctly in our snake body part if we do this computation here. So that's how we draw this snake. Now let's come back to our game scene and see how we draw the snake on the scene here. So let's go to the game scene here. Now in the init function, we are going to init the snake before we return true. And then because we initialize the snake, we should clear the snake as well. In this case, it doesn't matter, but to be complete, we should put the snake clear here. Maybe later we are going to add something to the snake, and then we need to clear the memory. So with this two functions in the init part and the clear part, we don't need to worry about memory leak. And then the render function is rather simple. After we render the background as we did last time, we just render the snake using the snake render function. And then we do need to render the fruit because this function will not render the fruit. To do so, we're going to remember that the scene map will contain the position of the fruit as well. So we use this information to compute the position of the fruit or the apple we need to draw in this case. And then we will draw the apple at the computed grid. And that is how we draw the fruit on the scene. So let's see the result once again before we leave. You can see that now you can see the snake is here and the apple is here. So that is for this episode. In the next episode, we're going to see how we actually move the snake and how we control the game logic using update and handle event. Thank you for watching.